welcome back everyone. In the previous video, we discussed the theory of QoS classification and marking. Now it's time to study how this works in real network. So in this lab, we will generate two types of traffic, voice traffic and web traffic, and then we'll configure the router to identify the traffic and mark the packets using DSCP values. So let's first look at the topology we'll use. It's very simple design. Here we have two users, Bob and Mike. They are connected. They have connected their laptops or PCs through IP phones, and those phones are connected to switch. Also, we have two servers. One is DSCP server, and another one is web server. DSCP server is to assign the IP for IP phones, and web server is for generating the web traffic so that Bob can access any web server and generate the HTTP traffic. So this is the high level overview of the topology. All the pre-configuration has been done, like IP configuration, VLANs configuration, connectivity and everything is already pre-configured. So before we start configuring the QoS, we can just verify if the traffic is working successfully. For example, first I will try to access the web server. Let me log in into this Bob's laptop. As you know, the server IP is 192.168.32.2. So we'll use that. Okay, let the browser open. Okay, so let me type the IP 192.168.32.2. Here you can see the website is opening. You can browse the website. Similarly, you can, okay. Then let's try to have a call between these two IP phones. The numbers and everything already registered. You can see 1001 is the landline number and 1003 is the other phone number. So what I will do is I will dial in 1003 just to make sure the call is working. As you can see, the phone is ringing. I will answer it on the other side and it will show you connected. So both our services are working fine. So this we already confirmed. So before configuring the QoS, let's quickly understand one important concept called MQC. Okay, also known as Modular QoS CLI. MQC is the framework Cisco routers use to configure QoS policies in a structured and modular way. So instead of configuring QoS with individual commands, MQC uses three main steps. Class map to identify traffic. First we need to define which traffic we want to match. For example, like voice traffic, web traffic, or specific IP addresses or ports. This is all done using class map. Then we have policy map. Like next we define what action to take on that traffic, and that is done by policy map. For example, mark packets with DSCP value, police the traffic, shape the traffic, or place traffic in a queue. This is all done using policy map. And the third we have is service policy. Like after these two steps, finally we apply the policy to an interface so that it affects the real traffic. This is done by using service policy command or service policy. So in this lab, we'll use MQC to classify voice traffic, classify web traffic, and then mark packets with DSCP value. So the first step will be QoS classification. Right? Classification is the first step where we identify packets based on certain characteristics such as source IP address, destination IP address, TCP or UDP port numbers, or application type. And then for that, we need to create ACL for both the types of traffic. We will identify the voice traffic using an access list. This access list will match traffic between two phone networks Like for example, I'll create one ACL 101 and I will put in the two subnets of the IP phones to match the traffic and in both directions. As you can see, I'll show in the diagram. As you can see, 192.168.30.0 is the subnet on the right side where IP phone 2 is connected, and 192.168.20 sorry, that is for data traffic. 192.168.21.0 and 192.168.31.0 is the subnet for voice. So that's what I have mentioned here. So we'll go ahead and apply this access list. As you can see, access list 101 permit these two subnets. For that, I'll get into the router, I'll log into the router, and then I'll configure it. I'll just paste it right away. So these two subnets are configured. Then we will create another ACL for web traffic. Okay, this ACL will match HTTP traffic going to the web server. So here what I will do is I will generate a traffic from Bob PC to the web server 192.168.32.2, and then I will allow these two subnets. If you see here, 192.168.20.0 is the Bob subnet and 192.168.32.2 is the IP of the web server, and then I will match it by using port number. You can use nbar here as well, like you can type in www, or I'll show you what to do. First let me type this part and I'll show you the option of typing both. If you type question mark, you can either put port numbers or you can put the application. You can use any of these. So our access list part is done. Let's move on to creating class maps. Okay, first step, we need to configure ACLs, then we will create class map. So a class map simply groups packet that match certain criteria. Like here we'll create two classes. One is voice, another one is web. So to create class map, this is the command. I'll show you. Let me log in into the device. Sorry, class map, and then you have two options: match any or match all. Match all is like a logical AND where you have to match all the statements, or match any is like a logical OR. Any of the statement matches, it works. So we just need to match any, and then I will give some name. You can just give any name. So I'll give as voice. And inside this class map, we'll match our access list which we created. And the command for that is match access group. And then you can type in the access list number. Similarly, I will create class map match any for our web traffic. And I will name it as web. Then I will call the access list 102. So with this, our access list is done, class map is done. Then we will move on to another step called policy map. So this is where we define the action for each classes. Like for voice traffic, we mark the packets with DSCP EF. In case if you don't know what EF is, EF stands for expedite forwarding, which is typically used for real-time traffic like voice. And for web traffic, we mark the packets with DSCP AF21. And these are the commands to configure the policy map. First, I will create a policy map with name QoS marking, and then I will call the class map which we created and then assign the values. So let me go back to the router. So first thing what I will do is from global configuration, I will configure policy map, and then you can put in the name QoS marking. Okay, inside the policy map, we will call our class map by typing class, and then you can call the class map. We created class map as voice and web. So first I will call voice, And then the next step is to assign the value. So to assign the value, this is the command set IP DSCP, and then you can choose from any of those DSCP values. The highest is EF because voice needs higher priority. So we will assign it as EF. Then within the policy map, we will call another class map, that is web, for web traffic. And then I will assign a little lower value called AF21. Okay, so these two uh, types of traffic are assigned different values now, and the remaining we should also define default, and for that you can type class default set DSCP default, set IP DSCP default. So it will just not mark anything. So this is our policy map. Class map is ACL is done, class map is done, policy map is done. Now we need to apply this QoS policy under the interface. So in packet tracer there are always limitations. So what I will do is I will apply it under the physical interface, because I want to mark all the incoming traffic on R1, right? So FA0/0 is our interface, this one. So let me hop on to FA0/0. Actually, this is the final step of QoS. I mean, we apply the policy on interface, and the best practice is to classify traffic as close to the source as possible, which we already discussed in the previous session, right? So which is usually we call it network edge. So we'll apply the policy inbound on the interface where traffic enters the router. As I said, FA0/0 is the interface. So the command for that is service policy input QoS marking. This is the policy map we created, right? So we are calling it here. Now what we will do is, before we generate the traffic, let's just quickly check the policy map packets. There are two ways. I can use show command, or I can do a packet capture. So first let me see if any packets are matched. Before we generate any traffic, you can see there are no packets match. This class map is for voice, and we are marking it with EF, and DSCP AF21 for web traffic. So all the remaining packets will be matched here. So let's go ahead and first let's generate the web traffic. The web browser is kind of slow, so 192.168.32.2, which is our server IP, servers accessible. We'll generate some traffic, and let's see now. As you can see, it is matching the packets now. Before there was a zero match. Now you can see it is matching the packets of AF21, but we didn't generate any voice traffic, so far nothing has been matched. Let me go back and generate a voice traffic. What I will do is I will call the other phone 1003. I will answer the call here. Here you can see the voice traffic is generated. So let me go back to the router and see. You should see some RTP packets matched. You can see here. So this count will increase. So this confirms our QoS classification and marking is working perfectly. If you want to check in more details, you can enable this simulation here and enable the packet capture and see the packets as well. Let's see if the packets are, let me show you some packets. First, let me do a browsing, and it should generate some packets. This packet, okay. So we should check some packets generated from R1 to switch 2, because this is where the QoS policies will be applied. R1 to switch to, yeah, this is the one. Let me check this one. You can see here the DSCP marking is applied. Let me generate some VoIP traffic. Let me call 1001. Oh, I think I need to disconnect there as well. Showing connected, why? Okay, I think some RTP traffic should be there. So far no RTP traffic. Okay, so yeah, I think no RTP traffic. Okay, let me generate some traffic. First the SCCP traffic will go. Now the phone is ringing. Let me answer it. Okay, now the RTP traffic has started. I need to check the traffic from R1 to switch to. Okay, no, not this one. Let's just filter it, only RTP. No TFTP, no HTTP. Okay, RTP traffic we need to check on R1 towards switch 2. Okay, let me stop it now. R1 towards switch 2. Okay, so this is the packet we need to check if the marking is successfully applied. Yeah, you can see here it is marking it as EF. There are some other commands if you want to verify if your class map is configured. Like for example, show class map. This will tell you what class maps you have configured. Then if you want to verify policy map, you can verify it by using show policy map. And if you want to see the packets, how many packets are hit, then that is the only command, show policy map interface FA0/0. If you can see, the packets are increasing and the classification and marking is working. That's it for this lab. In this lab, we verified how the classification and marking is configured and how it is verified. So just remember one thing, always QoS always begins with classification and marking. Once the packet is marked, the rest of the network can prioritize the traffic accordingly. That's it for this session. I hope this was informative for you. In my next session, I'll continue the explanation of another QoS tools, policing and shaping. So please do like, share and subscribe. Thank you.